Hi guys, so this video is on how to answer our 2019 question 7 speed question. Now we've got this graph here. The graph below represents the journey of a cyclist. Now just take a moment to pause this video and actually try understand what is this graph telling us. Right then, part A. Name an instrument that could be used to measure the time taken for the journey. So we can see here that we've got time for the cyclist on the x-axis going from 0 to 120 seconds. Not a very long cycle, it's only like 2 minutes. And in that distance, and then on the y-axis, we've got the distance that the cyclist is traveling from a certain point. Right then, so how could, they have taken the time for that journey? What instrument? Right then, so that instrument there could be a stopwatch. All right, that's an instrument for taking time. Now, part B, calculate the average speed of the cyclist as he travels from point A to point B. Right then, now sometimes these graphs can be a little bit difficult to interpret, but what we have to do is, first of all, we need to know the formula for speed, okay? And here's the formula for speed. So speed is equal to distance divided by time. Now, in terms of your car or something like that, so you would normally measure speed in kilometers per hour, okay, a distance per time. Some people still measure speed in miles per hour. Miles is the distance per time. In this case, we are looking at our speed in, well, we've got our distance in meters and our time in seconds. So our unit is going to be meters per second. Now we need to calculate the average speed of the cyclist as he travels from point A to point B. Right then, so on this graph, point A is here, and we're looking for the distance. So we just want to look on the y-axis here, and we're going from 0 meters to 100 meters here. So our total distance for our cyclist is going to be 100 meters. And we need to divide that by the amount of time it took for the cyclist to travel 100 meters. Okay, so now looking at on the x-axis, we've got 0 seconds, 20 seconds, 40 seconds here, and that's where point B is. So looking down here, the time it took to go 100 meters was 40 seconds. So that's what we're going to put in here. 40 seconds. Okay, and 100 divided by 40 is 2.5. Now, I don't want you to forget about your unit. Units are really important, and sometimes people get confused with what is the unit. Okay, here's the hint. Okay, our distance was measured in meters. Okay, and our time was measured in seconds. That there is our unit, meters per second. Meters per second. That means that our cyclist was doing 2.5 meters for every second. Now, next part of the question. So we've done the calculation. Describe the cyclist's motion between points B and C of his journey. Okay, so what was the cyclist doing between point B and C? Okay, so at that point, it was at 40 seconds to 60 seconds. So time is still going by, but the cyclist is staying, look here, at 100 meters. The cyclist isn't moving. So maybe the cyclist stopped to get a drink, stopped to tie a shoelace or something like that. But whatever the cyclist did, cyclist is not moving. Okay, stopped. Because as time is going on, the cyclist isn't getting any further away from where he started or any closer. Okay, so describe the cyclist's motion. And well, it stopped. Now, next part. The cyclist's speed as he travelled from point A to point B was less than his speed as he travelled from point C to D. Now, what evidence is there in the graph to support this? Right then, so let's just read that again. Pause the video for a second if you want and have a read it again. Right then. So they are telling us that the speed is less going from point A here to point B here compared to going from C to D. Well, there's one really big difference here. And we can see that the slope from A to B is less, whereas C to D has a greater slope. So we can see that. So the cyclist's speed as he traveled from point A to point B was less than his speed. So we want to say that, well, yeah, A to B had a less steep slope, indicating that the speed was slower. So from point A to B, the slope was less steep. That's one way to answer it. There is another way to answer it. And we can also see if we look at the numbers on our graph. Okay, the cyclist did 100 meters in 40 seconds here from A to B. So 100 meters in 40 seconds. But now the cyclist is doing from 100 to, well, over 200 in, well, 60 to 80. That's only 20 seconds. So here the cyclist took a lot more time to do 100 meters. So there was a greater time to do 100 meters. Now part E. Describe what the cyclist did at point D. Okay, what did the cyclist do up here at point D? Well, the cyclist was moving, let's say point A is his house or something like that. Okay, at 0 meters. Here at point B, he's 100 meters away from his house. At point D, he's a little bit over 200 meters away from his house. And then what the cyclist is doing, so we're really just reading the y-axis. The cyclist turned around and then went back down, let's say it was to his house or to home or wherever. So at D, the cyclist turned around because he was going away and now he's going back down. So the important thing for reading this part of the graph is you're really just looking at the y-axis. Okay? So the cyclist turned around. One common mistake for this is some people make the mistake of reading the graph saying, well, here the cyclist is going uphill. Here the cyclist is traveling on flat ground. Okay, there. Here the cyclist is going up a really steep hill. And now the cyclist is going downhill. And that is not the way to read these graphs. Okay, that's a really common mistake. You have to look on the y-axis. Okay, here the cyclist is 100 meters away from somewhere, a point. Then the cyclist is a little bit over 200 meters away from a point, and then returns back down. So turned around. Okay, I hope you found this useful, and best of luck in the rest of your studies.